This is our last part of our notes for the first unit. Yay! All right, we're going to go ahead and take these notes. This is all about imaging and how technology has changed with the different types of imaging and how we can see inside the body without doing surgery before surgery has to happen. So here is your essential question for your notes today. You are to compare and contrast the traditional X-ray imaging to the CT scan, or to CT scans in general. All right, so remember, this is a compare and contrast, so talk about how they are similar, and then also discuss how they are different, which one gives us some better options. All right, again, this is the last section of our notes for this first unit before we take a test. Woohoo! All right, so medical imaging. It's a technology that's been around for quite a few years, quite a number of years. The technology of X-rays has been around since the turn of the 1900s into the 20th century, but it took a few years to figure out after that that we could use it for medical purposes. All right. So medical imaging does allow visualization of your structures without surgery, and it's useful for a confirmation of diagnosis. All right. Next. Conventional radiography. This would be like your x-rays that you get like the dentist, or if you go and you've hurt yourself, you have to get an x-ray on your ankle because you twisted it. And what it is, conventional radiography is just your traditional x-ray, and usually what they do is they put you on a table and they bring the x-ray camera close to the area that they want to capture, and the x-ray technician will leave the room, okay, so that they're not exposed to the radiation. And what they also do sometimes is they'll put a lead apron or a lead sheet on top of areas of your body that are not to be exposed to the x-ray radiation. All right, so what this does, this is x-ray radiation. It's a single burst, because you can hear it go bzzz. Usually there's a buzzer associated with the machine. It produces a two-dimensional image on film. It'll expose the film. It's also known as radiography or x-rays, and oftentimes when it comes to these, it gives you poor resolution on soft tissues. So if you see this chest x-ray here, you can kind of see that there's portions of the lung in there, and you can see that the heart is there, but you can't see all the details inside there. And like the muscles and stuff holding the body together, you can't see those very well, but you can tell that they're there. All right, and then your hands and so on. Okay, so the next one here we've got is a CT scan, okay, which is called a computed tomography, okay, a CT scan. What it is, it's a moving x-ray beam, and unlike your traditional x-ray, what it would do is it would just bzzz, and it would give you a single exposure of what it captures. And here, this is a moving x-ray beam. And oftentimes, the image that's produced on a video monitor of a cross-section through the body. Like you can see here, there's a bunch of CT scans of somebody's brain, and it's showing you a cross-sectional arrangement. And a CT scan can move around and do a bunch of different things. And computer generated image reveals much more soft tissue detail than what your traditional x-ray will. For example, you can see kidneys really well, you can see gallstones really well, and if you look here, you can see actually all of the different parts of the brain because of this scan. All right. And for multiple scans of CT scans or computed tomographies, they can be used to build a 3D view of a person's body. Those three-dimensional tables that I was talking to about that they use in medical schools and stuff now, and in some labs, they have been produced because of this technology, the CT scan. Next, we have the digital subtraction angiography, or an angiogram. Angiogram, it's also called DSA for short. What this is, there is usually some kind of radiopaque material injected into blood vessels. Okay, so what that means is it's going to be some type of material that the film picks up on and registers. Okay. before and after images are compared with a computer program so they can see the different blood vessels. And the purpose of this is to see how the blood vessels are functioning to help rule out stroke and blood clots and stuff like that. Ultrasound. Ultrasound is a very fascinating technology. Instead of using radiation like some of the other techniques, this is the use of sound waves. All right, so an ultrasound here, this is high frequency sound waves emitted by a handheld device, and this is safe because it's sound. It's just sound. It's high enough frequency that we can't hear it, but it's not high enough frequency to cause any damage like surgery would. So it's safe, it's non-invasive, and it's painless. The image of the sonogram is displayed on a video monitor, and then we use it for fetal ultrasounds and examinations of your pelvic and abdominal organs, heart, and blood flow through your blood vessels. And this is just a sketch of a sonogram from somebody's abdomen. Okay, MRI. Anybody have to get an MRI? There's a lot of regulations that you have to follow to get an MRI, and that was found the hard way. We'll get there in just a second. Okay, so magnetic resonance imaging, or an MRI, is when your body is exposed to high energy magnetic fields. What happens here is that protons will align themselves relative to that magnetic field, and then the image that's produced is based off of that. And it's such a really detailed image from an MRI. Much like a CT scan, you can see a cross-sectional view with an MRI. And what it is, it's a pulse of radio waves or radiation used to generate the image on a video monitor. Okay? And it's really important that a patient that has an MRI must not have any metal in their body because of the really high magnetic field. The patient, if they go through an MRI machine, the metal will get ripped out of their body, and unfortunately that was found out the hard way by people. And what MRIs do, they really reveal fine detail within your soft tissues so that you don't have to go in and have surgery done. Okay, this next one here is a PET scan, or also known as the positron emission tomography. And this gives us a different view from what we've seen on the other images. And what this does is a substance will emit positively charged particles, and it's injected into the body. And then what happens is there's a collision with negatively charged electrons in the tissues that release gamma rays. And it's this high energy radiation that's detected by a camera, and then a computer will generate an image displayed on the monitor. All right? Well, that is the last form of imaging. Remember to go back, answer that essential question, and we will discuss this further in our next time we're in class. See you later.